This is lesson 10.1, multi-step equations. In pre-algebra, you have solved a ton of equations. So we're going to step that up a little bit, but you have a lot of the knowledge already to do these problems. Let's start with example 1. Tori won 40 small prizes playing carnival games at the summer festival. Later, she gave 2 to each of her friends. She only has 8 remaining. How many friends did she share her prizes with? Write and solve an equation. So when I read the question, how many friends did she share her prizes with? I know that that is my variable. I'm going to define F to stand for the number of friends. If you are struggling to set up this equation, it may help you to kind of think of it as a timeline. Where did she start? She started by winning 40 prizes. Okay, what did she do? Well, later she gave 2 to each of her friends. What operation would that be if you're giving away? And then where does she end up? Well, she now has 8 remaining. It's like a timeline. We're going to say she started with 40. She gave away 2 to each friend, and she ends up having, so equaling 8 currently. What would you do to solve this equation? Isolate your variable. This is a little bit tricky maybe if you, this is a common problem where we see students mess up. You see that minus sign, and so students want to add 40. Remember, you have to get rid of the 40. The minus sign that you see belongs to the 2F. So I'm actually going to subtract 40 from both sides to cancel out 40. The 40s cancel. Don't forget to pull the minus 2F down, including the minus sign, and that equals 32. Now it's a negative because you had more of the negative number, right? 8 minus 40 is negative 32. Next, what would you do to get F by itself? Divide by negative 2. A negative divided by a negative. Get that negative sign to show up there, sorry. A negative divided by a negative is a positive. We end up with F equals 16. Let's put a label on this. So the answer is 16 friends. You can always check your equations by plugging it back in. Let's plug it back into the beginning in our head. 40 minus 2 times 16. 2 times 16 is 32. 40 minus 32 is, in fact, 8. Now, the first one was the easiest. These get a little harder. The average of your last 3 test scores is 90. Your first score was 84, and your second score was 88. What was your third test score? And just to kind of help you understand this problem, I'm saying all tests were each out of 100 points. So those scores are the same as their percents. Okay, so what's a key word in this problem that's going to help you to set it up? Average. Do you remember how to find the average? Average is a fancy word for mean, so do you remember how to find your mean? See, you're going to find the average of your test scores, and if you remember what to do, that means you're going to add up your 3 test scores and divide it by 3 to get your average. They told you your average was 90. So this equation is definitely harder. What was your first test score? 84. Plus, what was your second test score? 88. Plus, what was your third test score? That's the question. That's what I don't know. So you can put a T for third test score or X, and I'm going to define my variable. X stands for my third test score. Okay, so you maybe have not solved an equation like this. Let's look at it. What would you want to do first? I'm thinking, we've got this 84 plus 88. Let's go ahead and add those 2 numbers together. What's 84 plus 88? 84 plus 88, what'd you get? 172, hopefully. So now I have 172 plus x divided by 3, all of that together, equals 90. When you're finding the average, remember we always add everything up first. Okay, so here's the thing. Your goal when solving an equation is always to isolate the variable. Sometimes the variable is trapped. When I look at this problem, it's trapped. Why? What's trapping it? Well, x is trapped in the numerator. There's a divide by 3 on there that's locking it in. So I need to get x by itself. In order to do that, I'm actually going to have to get rid of the divide by 3 first. If you can identify that, guys, you know what to do. See, the dividing by 3 is locking in the numerator. How do you cancel out divide by 3? Multiply by 3. So we're going to multiply both sides. Oops. We're going to multiply both sides of the equation by 3. And that's going to cancel out that denominator right there. Okay, so we have 172 plus x equals, what is 90 times 3? 270. I'm going to pull this equation up over here. I'm running out of room. Okay, so what do you do next? Now you know this is very easy. Get that x by itself, subtract 172 on both sides. Use your calculator to get that if you need help, although I think you can do this one without it, honestly. It's not 100, it's just under by 2, so 98. So your third test score was 98. Sorry for my writing with the stylus. Still getting used to it. Awesome. Just move this up a little here. Let's try the next one. Solve the equation. We have lots of negatives and decimals. You can do this problem though. Remember your operations with decimals. And remember, guys, what your goal is when you're solving an equation. Isolate that variable. Okay, so I would have to get rid of this minus 3.9 first. I would add 3.9 to both sides. Over here is the part that you have to think about maybe. How do you add decimals or subtract decimals? In this case, look, are they working together or against each other? They have different signs. They're working against each other. Okay, so really you're subtracting those numbers. Did you line up your decimal points? Take a minute and do that subtraction on your own. Did you get negative 1.8? And that's equal to 0.4 m. Great, now what would you do to get m by itself? Divide by 0.4, right? We're using the inverse operation there to get m by itself. A negative divided by a positive is a negative. If you need to, you could go over here on the side and you can do the long division for the decimals. If you don't have a calculator, I would hope this would be something you could do anyways. Remember, we move the decimal point over to make the number on the outside a whole number, so it's really 18 divided by 4. 4 fits into 18 4 times, 16 subtract, 4 fits into 25 times. When you push that decimal up, it's 4.5. So our answer is m equals negative 4.5. Good. Let's do a couple more here. Okay, so example 4 is definitely new for you. You could solve this equation with your current knowledge. You could just work with the fractions. If we look at this equation, you would want to add 13/20ths to both sides, and then you would want to multiply by the reciprocal 4/3 to get a by itself. I want to show you another way, a new way to solve this equation so that you don't have to work with the fractions. Instead, you actually can get rid of them. Remember, guys, with an equation, whatever you do to one side, you must do to the other. As long as you always do that, though, your equation is remaining equal. What I like to do is look at the denominators of the fractions, 4, 20, and 10. If you think about it, you could multiply this equation on both sides by one number, has to be the same number, and it will actually cancel out all three of those denominators. 4, 20, and 10, each of those could be canceled out by a 20. The way you choose what you're multiplying by is you're really looking for, a common factor of 4, really a common multiple, of 4, 20, and 10. So I'm going to put times 20 on the left and the right of this equation. Now, just to help you really see this, I'm going to actually show the times 20 by each term. Every term in the equation gets multiplied by 20. So you're going to have 20 times 3a over 4 minus 20 times 13 twentieths equals 20 times the negative 7 tenths. I think it's helpful to write the times 20 by each term so you can really see what cancels here. Let's look at the first multiplication here. This first term, 20 can cancel out the 4, right? 20 and 4 can reduce. That leaves a 5 behind. Now, when you multiply that first term, 5 times 3a, that leaves you with just 15a. It looks a lot simpler than 3a over 4. Let's look at the next one. We have a minus sign, and then we have 20 times 13 over 20. Again, the 20s cancel out. These ones are even better. They leave just a 1. And now you do the multiplication. So it's a minus 1 times 13 is just 13. Again, look how much simpler this is looking. Equals, last one, 20 times negative 7 tenths. You can cross out the 20 and the 10. You're reducing really those numbers. You can take a 10 out of both of those. That leaves a 2 and a 1. 2 times what's left, negative 7, is a negative 14. Now, I don't know about you, but I would rather solve this equation than the one that we started with. Look how nice it is. There's no fractions left. What do? We add 13 to both sides. Now you have 15a, because these cancel, equal negative 1. And then we divide by 15 on both sides. Remember, I don't need my calculator for that. I can leave it as a fraction. It's negative 1/15. It's reduced, it's simplified. There's your answer. Now again, this is just one way to do the problem, but this is the new way that you're learning in pre-algebra here at the end of the year. I like it. It makes the problem a lot easier. It's kind of one hard step in the beginning, and then the rest is faster. Awesome. Let's look at example 5. Find x if the perimeter is 40, right, and solve an equation. Okay, so you have to remember what perimeter is. Perimeter is the distance around this triangle, right? So how do you find the perimeter of that triangle? You add up all the sides. So that's what our equation is going to be. It's going to be 2x minus 1 plus x plus x plus 9 is equal to, what is the perimeter? They told you it's 40. There's your equation. Here we don't need to define a variable. They gave it to us. Now you just need to solve. You may be a little bit new to solving equations with multiple variables. It's just one extra step at the beginning. Take a look. We've got 2x, and always include the sign that's in front of it. So plus x plus another x. You've got to include those signs. Just combine those. Those are like terms with each other. 2x plus x is really just a 4x. Then combine your like terms that are numbers. We have a minus 1 and a plus 9. Always include the sign that is in front of it. That's part of the term. So minus 1 plus 9 is really just a plus 8, and that equals 40. You know how to solve this. Use your inverse operations to isolate your variable. It says find x if the perimeter is 40. X is equal to 8. Okay, one more here. I'm going to move this up. Solve the equation. All right, this one has a little bit more going on. You actually have a couple options that you could do for your first step. So don't think that if you solve this, a little bit differently than me, that you're doing it all wrong. Here's what I recommend though. As the equations start to get more complicated, I start at the farthest away point from x. So here's my variable. I want to solve for x, so that means I want to get the x by itself. I have a lot to get rid of. But remember, you already know you're undoing PEMDAS. You're getting rid of addition and subtraction first. Now, in this case, the plus 9 and the x, they're kind of like trapped inside of the parentheses. It's almost like they're in jail. They can't go anywhere. But the minus 4 I can get rid of. So I'm going to get rid of that first. I kind of start at the farthest point away from my x. So I have 3 parenthesis x plus 9 equals 32. Okay, what do I do from here? A lot of students want to do the minus 9 next. The problem is those parentheses, they're like prison bars. They're locking them in. So I want you to see them like that. They're trapping what's inside. You can't get those out. Instead, you need to think about, well, why do we have those parentheses? What's holding them up? What's the point of them here? Let's get rid of those parentheses by not needing them anymore. 3 can be distributed. And when I distribute 3, remember that's multiplication, I no longer need the parentheses. Really, that's what was holding them up. Now this is a normal equation to solve. You've done lots of two-step equations this year. And again, don't be thrown off if you get down to an answer like this where you can't finish it up. It doesn't come out to 32 divided by 4 equals 8. This is an answer as well. It's just x equals 5/3. You can leave it as a fraction, or you can make it a mixed number, 1 and 2/3, but both of those answers are fine. I wouldn't divide that on my calculator because it's repeating decimal. So the fraction form is better here. I hope this helps with some more advanced equations that involve multiple steps.